Hello people and welcome back to Maybe Ismail. In this session we will be doing complementary angles of trigonometric functions. Now you all should know what complementary angles are. Complementary angles are basically two angles adding up to 90 degrees. So if two angles add up to 90 degree you call it complementary angles, and if two angles add up to 180 degree you call it supplementary angles. So right now we'll be doing complementary angles only. Now let me just tell you that this complementary angles is a very small part of a bigger topic known as allied angles. I'll be making a separate video for allied angles, so if you're interested in that you can go and watch that video. But right now we'll be only dealing with complementary angles. So let us see what are the few things that we have in complementary angles. Okay, so the first thing is that sine of 90 minus theta is equal to cos theta. Next, cos of 90 minus theta is equal to sine theta. Okay, so you put up a co or you remove a co. Okay, so sine becomes cosine and cosine becomes a sine. So you either add a co or you subtract a co from the name of the trigonometric function. Okay, similarly we have tan 90 minus theta, which is cot theta, and cot 90 minus theta is equal to tan theta. And lastly we have sec 90 minus theta is equal to cosec theta, and cosec 90 minus theta is equal to sec theta. Okay, so these are basic things that you need to know, that 90 minus theta, whenever you have a 90 minus theta in the angle of a trigonometric functions, it becomes the complementary of itself. So sine's complementary is cosine, cosine's complementary is sine. So co just means complementary over there. Okay, so these are the things that you need to know. If you know all of these, we'll be able to solve a lot of questions based on these things. Okay, let us try to look at a question. So over here this question says, show that tan of 10 degree times tan of 15 degree times tan of 75 degree times tan of 80 degree is equal to 1. Now obviously I'll be starting with the left hand side. Okay, so in my left hand side I can see there are few angles that are complementary. Okay, we'll see what those complementary angles are. Let me just write this thing, 75 into tan of 80. Okay, I can very clearly see that 10 and 80 are complementary of each other because 10 plus 80 is 90, and I can see 15 and 75 are also complementary angles. I'll just change one of the things of the two pairs. Okay, what do I mean by that? See, listen very carefully. I can just ignore the tan 80 for the while. I can write the tan 10 as tan 90 minus 80, because see, 90 minus 80 is 10. So if I write 90 minus 80 instead of 10, I did not do anything wrong. Okay, that's one thing. I will not convert the tan 80, because if I convert both of them, it would still just become the same thing. It would just swap places. Okay, so it does not make sense. Okay, from the second pair, I would convert the first one again. So it becomes tan of 90 minus 75. 90 minus 75 is 15. So tan 15 can be written as tan of 90 minus 75. Okay, I changed just the two of these, like one of the two things of the pair, and the other can remain as it is. So tan 75 and tan 80, these two things can stay however they are. Now it is not necessary to change these ones. You could have changed the other one also, which I left. Okay, now as per the rules, tan 90 minus theta is cot theta. So tan 90 minus 80 can be written as cot 80 times tan 90 minus 75 can be written as cot 75, and everything else remains the same. So tan 75 times tan of 80. Now we know tan is the reciprocal of cot and cot is the reciprocal of tan. So over here cot 80 can be written as 1 upon tan 80, 1 upon tan 80 times the cot 75 can be written as 1 upon tan 75, and everything else is as it is. So tan 75 times tan 80. Let us just cancel out. So tan 80 goes away with this tan 80, the tan 75 and the tan 75 cancels, and I'm finally left with 1, which is exactly what my right hand side is. Okay, let us move ahead to the next question. Now this one says, show that all of these is equal to 2. Let us start with the left hand side. Now left hand side is sine of 42 degree times sec of 48 degree plus cos of 42 degree times cosec of 48 degree. Okay, I can very clearly see that 42 and 48 adds up to 90, so they are complementary of each other. Okay, I'll change one of them. So can I write sine the 42 can become 90 minus 48 because 90 minus 48 is 42. So instead of 42, I'll write 90 minus 48. I should not change the other one, so the sec 48 remains as it is. Plus, in the second one also, I'll do the same thing. I can do one of them. I don't have to do both of them, and I don't have to necessarily do 42 because I've already done 42. Okay, I could do any of them. I'll still do 42. So this becomes cos 90 minus 48. And then the cosec 48 remains as it is. Okay. Now, sine 90 minus theta is cos theta. So, sine 90 minus 48 is cos 48 times the sec 48 remains as it is plus cos 90 minus theta is sin theta. So, cos 90 minus 48 is sin 48 times the cosec 48. Now, we all know that cos and sec are reciprocals of each other, sin and cosec are reciprocals of each other. So, this can be cos 48 times the sec becomes 1 upon cos 48 plus sin 48 is as it is and the cosec can become 1 upon sin 48. Just cancel out the cos 48 and cos 48, sin 48 and sin 48. I am left with 1 plus another 1 and that finally becomes equal to 2. Okay. Next question. This one says express each of the following in terms of angles between 0 and 45 degree. Now this thing could turn up in your MCQs or something. Okay. Where the angles given are more than 45 degree, I have to report it in terms of angles less than 45 degree. Let us try the first one. So, sine 59 plus tan 63. Now, 59 can be written as 90 minus something. Okay, we'll have to think in that way. So, it can be written as sine of 90 minus 31. Okay, 90 minus 31 is 59 plus tan of 63 can also be written as 90 minus, how much is it? 27. Let me just confirm. I don't know why I'm getting confused. Is 90 minus 27 63? Yes, it is true. And 90 minus 31? Yes, it is 59. Okay. So you have to write it in terms of 90 minus something. Now you use the rule. Sin 90 minus theta is cos theta. So sin 90 minus 31 is cos 31 plus tan 90 minus theta is cot theta. So it becomes cot 27 and that's it. See, now the angles 31 degree and 27 degree are basically less than 45 degree. It is between 0 and 45 degree and that is exactly what my question says. I have to report it in terms of angles between 0 and 45 degree. Okay, let us look at the second one. So this thing is cosec 68 degrees plus cot 72 degrees. Now, cosec 68 can be written as cosec 90 minus 22. 90 minus 22 is 68 plus the cot 72 can be written as cot of 90 minus 18. Okay, 90 minus 18 is 72 and 90 minus 22 is 68. Now we use the rules. Cosec 90 minus theta is sec theta. So this becomes sec 22 plus cot 90 minus theta is tan theta. So this becomes tan of 18 and that is it. 18 degree and 22 degrees are angle between 0 and 45 degrees. That is it. Okay. Next question. This one says show that sin A upon sin 90 minus A plus cos A upon cos 90 minus A is equal to sec A times cosec A. Obviously, we'll be starting with the left hand side. So the left hand side is sin A upon sin 90 minus A plus cos A upon cos 90 minus A. Okay. Now we know the rules. Sin 90 minus theta is cos theta and cos 90 minus theta is sin theta. So we can use those rules in the denominators. So sin A upon the sin 90 minus A can be written as cos A plus this cos A is as it is. In the denominator, cos 90 minus A can be written as sin A. Now we just need to cross multiply. Now you can obviously understand that this is a very basic question which we have already done in the previous sessions. Okay. So you have to just cross multiply. Sin A times sin A is sin square A plus cos A times cos A is cos square A, and in the denominator they two just get multiplied with each other. So it is cos A times sin A. In the numerator, sin square A plus cos square A is equal to 1. So it becomes 1 upon cos A into sin A. Okay, so 1 upon cos A is sec A and 1 upon sin A is cosec A, and that's it. That is my answer. Simple. Okay, next question. I have a lot of things and I have to prove that is equal to 0 degree. Let us just start with the left hand side. I won't write the entire thing again because I'm too lazy to write it. I'm just telling you that we need to use the complementary angle formulas. Okay, so I can see a cos 90 minus a, I can see a sec 90 minus a. Wherever I see a 90 minus something, I just need to correct that thing. Okay, so let's start with the left hand side. So my left hand side is sin a times cos a minus this sin a is as it is times cos 90 minus a. Cos 90 minus theta is sin theta. So this thing becomes sin a into the cos a. In the denominator, I'll have sec 90 minus a. Now sec 90 minus a is cosec a. So this becomes cosec a minus, I'll be doing this one now. Okay, so cos a remains as it is. Sin 90 minus a can be written as cos a times the sin a is as it is. In the denominator, cosec 90 minus a can be written as sec a. Now let us try to simplify this thing. So this would be sin a times cos a. Now if you see very closely, this is a sin a, this is a sin a. Sin a times sin a is sin square a. I have a cosec a in the denominator. When cosec a flips, it becomes sin a, like it becomes a reciprocal, and sin and cosec are reciprocals of each other. So cosec comes to the numerator and becomes a sin. Okay, so the cosec goes to the numerator. So I'll have three sines in the numerator, sin a into sin a, and that cosec a, that also becomes a sin a. So I can write it as sin cube a times the cos a remains as it is. Then in the other one, I have a cos a, I have another cos a. This sec a can also go to the numerator and become cos a because it's a reciprocal. So I have a total of 3 cos a's. So this becomes minus cos cube a times sin a. And please try to understand that these cos's are being multiplied. So you will have to put up the sign. Okay, like cos a times cos a times cos a is cos cube a. When you add it up, it becomes 3 into cos a. Okay, now let's see what can be done. I can very clearly see that all the terms that I have over here, like the first term, the second term and the third term, all of these terms have at least one sin a cos a, and they can give me out a 1 sin a and cos a. Okay, so sin a times cos a can be factored out. Let's see what I am left with. The first term has given everything that it had, so it would just be left with 1 minus. From the second term, out of the 3 sines, one of the sign is gone, so I'll just be left with sin square a. The cos a is already gone, minus. From the third term, out of the 3 cos's, one of the cos's gone, so I'll be left with cos square a, and the sin a is also gone. Now you have two options. Either write sin square a plus cos square a instead of 1, or factor out a minus sign from the second 2 terms. I'll show you the second way. Okay, so sin a times cos a, this is 1 minus, I factor out a minus sign, this becomes sin square a plus cos square a. And now we all know sin square a plus cos square a is equal to 1. So this is sin a times cos a times 1 minus 1. Now 1 minus 1 is a 0. So this would be sin a times cos a times 0. Now anything into 0 is just 0. So this answer is also 0, which is exactly what my right hand side is. Okay. Next question. Now this one says, for triangle ABC, show that sin of a plus b upon 2 is equal to cos of c upon 2. What is this? This is so strange, so silly. Yeah. Okay, nothing strange, nothing silly. We know that in any triangle, we have 3 angles, and the sum of all 3 angles is 180 degree. We have to use that logic. Okay, what do I say? I'll say a plus b plus c is equal to 90 degree. 180 degree. Okay, now in my left hand side, I need a and b. I don't need the c. So I just send the c to the other side. So it becomes a plus b is equal to 180 minus c. I can also see in the left hand side there is a 2 in the denominator. So I will divide everything by 2. So this becomes a plus b upon 2 is equal to 180 minus c upon 2. And now I can see I need a sine of a plus b upon 2. So I take sine on both the sides. So it becomes sine of a plus b upon 2 is equal to sine of 180 upon 2 minus c upon 2. What did I just do over here? I just distributed the denominator with both the terms in the numerator. Okay. Now 180 upon 2, 2 times 1 and 2 times 90. So in my right hand side, I have sine of 90 minus c upon 2. Now we know sine 90 minus theta is cos theta. So this would now become cos of c upon 2, and this is equivalent to sine of a plus b upon 2, and that is exactly what is asked to me in the question. Okay, so whenever it says that I have a triangle ABC and we have to prove sine of some angles being added up or half of some angle, you have to use this logic. Okay, fine, let us try this question. It's a similar kind of question. It says for triangle ABC, show that tan of all of these. So I'll say, okay, fair enough. I know that A plus B plus C will be equal to 180 degree. I only need B and C this time. So see, in the previous question, we needed A and B on the left hand side. Over here in this question, I just need B and C on the left hand side, which means I'll have to shift the A to the other side. So it becomes B plus C is equal to 180 minus A. Now, I don't need B plus C, I need B plus C divided by 2. So I just divide both sides by 2. So it becomes B plus C upon 2 is equal to 180 minus A divided by 2. Now, I need tan of B plus C upon 2. So I take tan on both the sides. So this becomes tan of B plus C upon 2 is equal to tan of, can I just write this thing as 180 upon 2, which is 90 minus A upon 2. Okay. Now, we know tan 90 minus theta is cot theta. So, tan 90 minus A by 2 is cot A by 2. So, the answer is cot A by 2, and that is exactly what is asked in the question. Okay. The next question. This one says in triangle ABC, right angled at B. That's super important information which is given. Right angled at B, which means that angle B is equal to 90 degree. Okay. That is like really important. It says find the value of all of these things. Okay, let's see what is to be done. Can I write this thing as sec A times cosec C minus tan A times cot C upon sine, not B, because I already know that B is equal to 90 degree. So I'll just write sine 90 degree. Okay. Now, sine 90 we all know is 1 from the standard angle table. Okay. So this thing now becomes sec A times cosec C minus tan A times cot C. What do I do now? Because I can see so many angles and I have nothing left over here. But see, that thing, the information that was given to us was not just a very partial information. Okay. When it says that angle B is right angle, which means it is 90 degree, we know that the sum of all angles in a triangle is 180 degree. And if B has already taken 90 degree, the other two will have to share the remaining 90 degree, which means that A plus C is also equal to 90 degree. If B is 90, then the other two would also add up to 90 degree. Okay, only then the sum would become 180 degree. Okay, so over here, can I just say that sec of A can be written as sec of 90 minus C, because see, A is actually 90 minus C. The C can go to the other side. Okay, so instead of A, I have written 90 minus C times the cosec C minus tan of A can be written as 90 minus C times the cot C. Okay, we know sec 90 minus theta is cosec theta. So this becomes cosec C times cosec C minus tan 90 minus theta is cot theta. So this becomes cot C times cot C, which is basically cosec square C minus cot square C. Now we know the three identities: sin square theta plus cos square theta is 1, sec square theta is 1 plus tan square theta, and cosec square theta is 1 plus cot square theta. So I'll be using that identity. Cosec square theta is equal to 1 plus cot square theta. If I send the cot square theta to the other side, so cosec square minus cot square is basically equal to 1. So the final answer of this thing, cosec square C minus cot square C, will be equal to 1. Okay. Next question. Here it says, in each case given below, find the value of angle A where A is between 0 and 90 degree. This is how you read it, that A is between 0 and 90 degree and both included. Okay, because there is an equal to sign with the less than and greater than sign. Okay, so A can be 0, it could also be 90, but it is supposed to be between 0 and 90 degree only. Okay, let us see what is given to us. So here it says sine of 90 minus 3A times cosec 42 is equal to 1. What I do is, I'll write this thing as sine of 90 minus 3A is equal to 1 upon cosec 42. I just send this cosec to the other side. Okay. Now I know that cosec is a reciprocal of sine. So this thing becomes sine of 90 minus 3A is equal to sine of 42. Okay. So now I can see that both the sides are sines of something. Okay, so sine of something is equal to sine of some other thing. So if the sines of two different things are same, then those two things also have to be same. How do I explain this to you? I don't know. Yeah, so let's see, this is the lens cap. If I make a juice out of this lens cap, and if I make a juice out of this pen, okay, and both the juices are same, then you can say that the lens cap and the pen are the same thing, okay, because the juice of both the things are same, okay. So that is why sine of something on the left hand side and sine of some other thing on the right hand side are same, which means those two things are themselves equal, okay. Don't be a noob and cancel out the sine and sine on both the sides, okay. It is not supposed to be done because sines do not get cancelled out like that. It is not an algebraic term, okay. So you can just neutralize sine, or you can just say that we are taking sine inverse, and that's a big thing. Just consider that these two things have to be equal. That's it, okay. So I can say 90 minus 3a is equal to 42. Now this is a very basic plane equation, we can solve it. So 90 minus 42 is equal to 3a. 90 minus 42 is 48, is equal to 3a. So 48 divided by 3, a would be equal to 16 degree. That's it. And it is also between 0 and 90 degree. Okay. Let us try another question. This one says I have to again figure out what a is, and some other expression is given to, equation is given to us. So cos of 90 minus a is equal to 1 upon sec of 77. Flip the sec and make it cos. So this becomes cos of 90 minus a is equal to cos of 77. Now we can just compare both the sides and say that 90 minus a itself is equal to 77. So 90 minus 77 is equal to a, and finally a would be equal to 13 degrees. Okay. Okay, next. Now this one says prove that cos of 90 minus theta times cos theta upon cot theta is equal to 1 minus cos square theta. I'll be starting with my left hand side. So the left hand side is cos of 90 minus theta times cos theta, the whole thing upon cot theta. Okay, we know the rule, cos 90 minus theta is sin theta. So I can just write this thing as sin theta times cos theta upon the cot theta can be written as cos theta upon sin theta. Now this sign over here can come to the numerator because it is the denominator of the denominator. Okay. So when it comes to the numerator, there is already a sign in the numerator. So it becomes sin square theta. And this cos and this cos, they too can get cancelled out. So I'm just left with sin square theta. Now we all know sin square theta is actually 1 minus cos square theta. Okay. I'll just write the identity. Sin square theta plus cos square theta is equal to 1. Okay. So sin square theta is 1 minus cos square theta, and that is exactly what my right hand side is. So 1 minus cos square theta is your answer. Next one. This says evaluate all of these things. Okay. Now in this thing, if you see, you have a few silly angles and you have a good angle also. Okay. Let us talk about the silly angles first. I can see 34 and 56 are silly angles, but they are not very silly because they are complementary of each other. Because 34 and 56 adds up to 90 degree. Also, the 18 and 72 are the silly angles, but they also are complementary. They are adding up to 90 degree. And 30 is a very good angle. I like that angle. Okay, I like 30 degree. Okay, because it is a standard angle. Now, what do I do? Can I write the 34 as 90 minus 56? Surely. So I'll just write it as sine square 90 minus 56, because 90 minus 56 is itself 34. So not really a problem. Plus, do not change the other one. You have to just change one of them. Otherwise, you'll just get into a loop of just probably figuring out for life. Okay. So this thing is sine square 56 plus the 2 tan 18 can be written as 90 minus 72, because 90 minus 72 itself is 18, and the tan 72 is as it is, minus I have a cot square 30. Do I know what cot 30 is? Because yeah, 30 degree is a very good angle. Okay. So cot 30 in the table, if you do not know, if you only know for tan, so tan 30 is 1 over root 3, you just flip it. So cot 30 is root 3. So I'll write root 3 squared. Okay. Now let's see what can be done. The sine 90 minus theta, we know sine 90 minus theta is cos theta. So sine square 90 minus 56 can be written as cos square 56. Plus I have sine square 56 plus 2 tan 90 minus theta can be written as cot theta. So tan 90 minus 72 can be written as cot 72 times the tan 72 minus the square of root 3 is just 3. Okay. Now we all know that cos square theta plus sin square theta is equal to 1. So cos square 56 plus sin square 56 will be equal to 1 plus 2. Cot 72 can be written as 1 upon tan 72 times the other tan 72 minus the 3. Tan 72 and tan 72 just goes away. So I'm left with 1 plus 2 minus 3. 1 plus 2 is 3 minus 3, which is just equal to 0. And the final answer of this thing is 0. Okay. Let us come to the next question. So here I have evaluate again all of these things. Similarly, we'll just see what happens. 57, 33, silly angles, but they are complementary of each other. 44, 46, silly angles, but they are complementary of each other. 45 degree is a good angle. 60 degree is also a very good angle. Okay, because I know those angles are from the standard angle table. Okay. Now, what do? Can I write the cosec square 57 as cosec square 90 minus 33? You can also change the 33. You can write the 33 as 90 minus 57. It's your wish. Okay. Minus the tan square 33 remains as it is. Plus cos 44 can be written as cos of 90 minus 46 times the cosec 46 is as it is minus root 2. Now, I know cos 45 is 1 upon root 2 minus. I know tan 60 is root 3. So, I'll write root 3 and then I'll have to square it. Okay. Cosec 90 minus theta is sec theta. So, cosec 90 minus 33 is sec 33 and I'll have to obviously put up a square. So, sec square 33 minus tan square 33 plus cos 90 minus theta is sin theta. So, cos 90 minus 46 is sin 46 times cosec 46. Over here, the root 2 and the root 2 just goes away. So, I'm left with minus 1 minus the square of root 3 is just 3. Now, the first term over here, sec square theta minus tan square theta is equal to 1. So, instead of that, I'll just write 1 plus the sin 46 is as it is. Cosec can be written as 1 upon sin. So, it is 1 upon sin 46. Minus 1 minus 3 is minus 4. Okay. Sin 46 just goes away. I'm left with 1 plus 1 minus 4. 1 plus 1 is 2 minus 4. Finally, my answer is equal to negative 2, and that is it for this video. I will be seeing you in the next one and hope you like it. And just a reminder that all of the things that I'm writing over here on the tab and all these questions are in the description. They have been put up as a PDF thing. You can just download it and refer to it. Thank you so much.